All right, let's dive right in. Welcome, everyone. Today, we're unpacking what's quickly becoming the absolute definitive credential for this new AI era. We're talking about the Claude Certified Architect program, or CCA Foundations. If you're looking to figure out how to build actual production-ready AI systems, well, you're in exactly the right place. You know, the AI landscape has completely shifted over the last year. We are way past that initial novelty phase. And now we really need to ask ourselves a pretty fundamental question. Are you just prompting, or are you actually architecting? Like, are we just chatting with models to get a quick answer, or are we building reliable enterprise-grade systems that run autonomously?
I love this perspective because it hits the nail right on the head. This isn't just some conceptual AI literacy badge. It's a systems design exam. That completely captures the reality of the CCA Foundations exam. It's not checking if you know what an LLM is. It's verifying that you can legitimately ship production-grade applications at scale using Anthropic's ecosystem.
So here's our roadmap for today. We'll cover the AI architecture era, what the CCA actually is, break down the exam domains, talk about avoiding common anti-patterns, and finally, go over a solid exam prep roadmap. Okay, part one, the AI architecture era. Let's put this into perspective. $100 million. Anthropic hasn't just tossed a test out there into the wild. They've backed their new Claude Partner Network with a massive $100 million investment. And that's specifically geared towards training, co-marketing, and dedicated technical architecture roles. I mean, we are talking about serious enterprise infrastructure here. And the industry's response? It's been absolutely massive, with major consulting firms like Cognizant training up to 350,000 employees globally. Having this credential is fast becoming a baseline expectation. At that scale, if you're in any sort of delivery role, this isn't just a fun differentiator anymore, it's literally the floor. Moving on to part two, what exactly is the CCA? So what's really interesting here is the sheer rigor of this test. We're talking 60 multiple-choice questions. It's strictly proctored, so that means no documentation, no external tools, and absolutely no asking Claude for help while you take it. It's scored on a 100 to 1,000 scale, with the passing score sitting right at 720. But here's the most important part. It's entirely based on realistic industry scenarios. It completely tests your ability to make tough architectural trade-off decisions under pressure. All right, part three, breaking down the domains. When you look at the breakdown, almost half the exam focuses purely on agent architecture, which makes up 27%, and Claude code configuration at 20%. Notice that prompt engineering is only 20% of the whole shebang. That really proves this is not just a prompting fundamentals test. You've also got tool and MCP integration coming in at 18%, with context management and reliability rounding things out at 15%. Now, if you only have time to deeply study two areas, for sure make it these key concepts. For agent architecture, you've got to understand how to design agent loops, how to properly delegate tasks to specialized subagents, and how to use lifecycle hooks. And for code config, you absolutely must know how to set up your Claude.md hierarchy and exactly when you should be using planning mode versus direct execution for code generation.
Let's jump to part four, avoiding common anti-patterns.
First up, we have a classic rookie myth. Rely on phrases like "I'm done" or "task complete" in the text output to know if your agent loop is finished. The reality? You must programmatically check the stop_reason API field for end turn. Seriously, never rely on Claude's natural language to figure out if a task is actually finished. That approach is totally unreliable, and it's going to break all the time. Here's another major one. The myth is that you should give an agent like 18 different tools just to maximize its capability. But the reality? You need to constrain your agents to a maximum of 4 to 5 highly scoped tools. Think about it. Giving an agent 18 tools is basically like hiring a brand new employee and giving them admin access to every single system from day one. They're going to get overwhelmed and start doing things outside their lane. Keeping them down to 4 or 5 relevant tools is exactly what keeps them precise and reliable. Next myth? Just dumping all your rules, your tone guidelines, and your preferences into a single user-level Claude.md file. The reality is you want to split those rules into project-level and path-specific layers. Don't dump everything into one giant file that just blindly eats up your token budget every single session. Use a layered approach. That way conventions only load when you're actually modifying the relevant files. Okay, this last one is absolutely vital. The myth is that you can use detailed prompts to enforce critical security rules. Reality check? You have to use programmatic hooks to physically block restricted actions. The crucial takeaway here is this. Prompts are just suggestions, but hooks are the absolute law when it comes to financial, security, or legal boundaries. If it has to work 100% of the time, block it at the system level. Do not rely on a prompt. Finally, Part 5, your exam prep roadmap. So, you really need to lay the groundwork first. Read through that official 40-page exam guide thoroughly. Complete the free Anthropic Academy 101 and Fluency courses. But honestly, most importantly, get hands-on. Build Agent SDK loops, set up local MCP servers, and really practice plan mode versus direct execution until it's second nature. Now, for your deeper study sessions, take a cue from candidates who have already passed. Create a single Claude project and use 3 distinct system prompts to turn Claude into your own personal study coach. Step 1. Build a learning coach to strictly explain concepts from the exam guide. Step 2. Build a practice coach to drill you with difficult, nuanced distractor formats. And Step 3. Build a mock test prompt to actually simulate exam conditions. Have it randomly test you on scenarios without giving away the answers until the very end. You know, understanding all these principles doesn't just help you pass a test. It fundamentally changes how you build. You aren't just chatting anymore, you're designing robust, enterprise-grade systems that can truly work autonomously. So the big question I want to leave you with today is this. Knowing what you know now, how will you architect your next AI project?